Hi, I'm Andrew Culhane, Chief Commercial Officer at Torc, here at ACT Expo for a fireside chat talking about Level 4 trucking, LiDAR, and scaling up. You can have the three panelists introduce yourselves.
My name is Joanna Buttler, and I lead the Autonomous Technology Group for Daimler Truck globally.
Peter Schmidt, CEO of Torc Robotics.
I'm Soroush, co-founder and CEO of Aeva.
Excellent. So with that, we'll kick right into the questions. Starting with you, Peter, how would you describe the market opportunity for Torc as we push into Level 4 trucking?
I mean, it's just enormous. There's a big driver shortage in US. The freight market is enormous. There's only growth. And this technology is now right for prime time. So there's a ton of growth in front of us.
Excellent. Over to you, Joanna. As part of Daimler, one of the pioneers in trucking, how do you see this providing benefits to your customers through autonomous trucks?
Yeah, as Peter said, if you think about our daily lives and all the freight that has to be moved, the trucking industry last year generated over $940 billion in revenue, right? So that means a lot of freight, a lot of goods moved across the country. And it represents about 73% of all freight moved is moved on trucks. So this is a huge opportunity. If we can make that freight movement even more efficient and safer and reliable, then that is a huge opportunity for our customers, but also for society. And asset utilization is so critical for our fleet. So if you have an expensive asset that sits there 50% of the time, that's not good unit economics. But if it can run virtually 24/7, that is a good business case for them.
Excellent. To build off of that one, as we talk about that business case, what is it going to take to make this a scalable, supportable product?
Well, it really starts with the foundation of this product, and that is a vehicle platform that is capable of basically executing the commands of a Level 4 system. And as Daimler Truck, we are developing a Level 4 scalable, propulsion agnostic vehicle platform that is basically safe and reliable to work with all the Level 4 technologies, especially with the Torc Robotics virtual driver. And in order to achieve that, we basically translated 1,500 requirements into a redundant chassis platform. That means redundancy in braking, steering, your power net system, so you have continued power generation and distribution, as well as ultra-fast communication architecture. And then from there, you want to make sure that you have an integrated product. So, you integrate the hardware, the autonomous driving hardware, and we will hear about that in a little bit more. And that, to make it buildable and scalable, you have to ensure that you integrate that seamlessly into your manufacturing processes, but also later on into your service processes and maintenance processes. So our customers can truly utilize and leverage this technology just like they utilize trucks today.
Excellent. So Peter, one more for you. As we understand where we're in this current landscape, what really makes us believe in that 2027 timeline to launch at scale?
A lot of technologies are just now ready for prime time and for being implemented. We are definitely out of the prototyping phase, out of the demo phase, out of the R&D phase. Now it's all about productization and building a real business. But in the meanwhile, the software is there with all the AI and Gen AI advancements. We have a virtual driver that can handle everything which is required on our ODD. We can prove it in simulation. We can prove it in real world. But other than that, this requires a ton of computing power. So automotive grade compute on embedded hardware, they are available at target cost. And of course, the great foundation that we get from Freightliner. And it requires a ton of sensors, automotive grade sensors that have a far out range. And that was missing until I would say 1 or 2 or 3 years ago. And one critical component, by the way, and that's why Soroush is with us, is also the LiDAR, the laser scanner, and especially what Aeva offers to us. It's a 4D LiDAR that on top to the typical time of flight adds the Doppler effect, and that extends range. And range is super critical, especially in trucking, because it's an 80,000 pound vehicle, driving at 70 miles per hour. So we need more range to the front and even more range to the back compared to a car. And now these sensors are available.
Excellent. Well, a great transition. Soroush, how can you explain how Aeva's technology helps bring that Level 4 trucking to life?
Sure, yeah. I think one of the things that we've seen in the past number of years is, as Peter mentioned, the requirements for achieving highway speed autonomy at scale is become very clear. And this really what means is that what was available so far simply wasn't sufficient, right? What's available today is not sufficient. So, and with what we see in time-of-flight LiDAR, or what's called 3D LiDAR, you can measure objects at long distances, but you have limitations. For example, distance is what you can measure. When you add that extra dimension of velocity, that's where we come in, as Peter mentioned, you can see things in a way that is not been possible before. You can see objects at further ranges. You can have added confidence that what you see is something that you should care about from an autonomous stack standpoint. So, for us, obviously a big focus besides performance is really scalability and integration, which is, I think, is very important as we work with, of course, Joanna and Peter's team on the integration side of the house. Having a sensor product that is actually automotive grade and can achieve the requirements for trucking is quite important. So that's what we're excited about.
Excellent. Well, another one back to you. Peter mentioned seeing this technology mature. In terms of FMCW, what makes it so innovative? What really led to that breakthrough? And how is it really different from other technologies that are out there?
Yeah, I think we could spend probably hours talking about this, and maybe not the most exciting topic to do that. But I can tell you what is exciting is that I think first of all, at a high level, as I mentioned, what this really enables, this FMCW technology, is that gap of achieving highway speed autonomy, right? Like today, you can see maybe even cars on the road, passenger vehicles that are maybe doing 30, 40 miles per hour. But to get to that kind of higher level automation, highway speeds, that's something that is missing. Sensors, compute, and algorithms all as a package together, right? But FMCW, why it really is differentiated is that, first of all, besides the fact that I mentioned the velocity dimension, the ability to measure down to a single photon allows the sensor to actually see much further ranges, but also do better in kind of poorer weather. So when weather gets a little bit more challenging, rain, snow, things like that, it can do better than what's typically out there today. So availability, reliability is a key topic in addition to just performance. And then the last topic is obviously, the coolest technology in the world by itself is not sufficient, right? You have to have a product that actually can scale, right? And so being able to integrate everything down at the chip level is something that we have been able to do at Aeva. Putting LiDAR on a silicon photonic chip module allows us to actually get to something that is highly scalable, reliable, no fibers in the system. It's, can achieve that level of maturity and reliability performance needed when you have a vehicle that's moving and shocking, vibing so much.
All right, so real common themes there around scalability, around the technology, and around being set up to have that level of reliability and performance. Maybe shifting gears a little bit, over to you, Joanna. Daimler Truck has just announced the autonomous Freightliner e-Cascadia sitting here to my right. It really combines those goals of electrification, autonomy, and decarbonization by 2039. How does autonomy really fit into that layering on top of the electric?
Yeah, so first of all, we're really proud that now was the time to combine these two technologies. Why? Because we have a series e-Cascadia already in production, and our autonomy has evolved to a state that we can now bring these two together, first in a hardware integration project, which we see here. And why autonomy can actually benefit electrification or electric vehicles is because, again, an autonomous vehicle does never have to sleep or stop or get distracted. So that means, again, utilizing this asset more consistently, more frequently. And on the other hand, I think autonomy can also benefit the efficiency and the range of the electric vehicle itself, because it can operate, at the best and optimal performance of the vehicle. So, and therefore stretching the range and not, reducing it.
Excellent. Well, over to you, Peter. What would you see as the biggest opportunities going forward? We've heard about electric. We've talked about that product scalability. What are the opportunities that we see going forward?
I mean, this truck is a beautiful and wonderful example that our Torc driver, the best truck driver, virtual truck driver you can imagine, just can drive everything. It can drive a diesel sleeper cab, an electric day cab, and any free combination of it and anything you could imagine. So Class 6-7, US, Europe, Asia, maybe even shuttles, there are really no limits. Once it's unlocked. We unlock it with that truck behind me, the Cascadia Class 8 diesel sleeper cab, but the opportunities afterwards, they are just unlimited. And that's super exciting.
Excellent, and lots of volume out there across all of those platforms as well.
Oh yeah.
Peter, you just talked about the no limits aspect of this. What do we see for scale in the early days building up to that no limits period?
Yeah, while in 27 we are talking mainly about US and we call it the Sun Belt, but even that we are talking about thousands of trucks, I mean globally, but also US, or in the year 2030 we are talking about 10,000 of trucks of opportunity, and this is really exciting, and trucks that turn over a lot because after 3 years that they have reached the mileage, they can run 24/7, 365 days a year. And they will collect a lot of mileage in pretty short time. So
Strong
a lot of scaling opportunities there.
Excellent.
And for us, by the way, this means that obviously we have to be ready to produce in the hundreds of thousands of sensors, because that's, multiple sensors per vehicle is something that becomes critical. And so startup production is not just it's going to be steady ramp for many years. Like, we have to have that capacity available for Daimler, for Torc to be able to actually scale in the US and then eventually globally.
Excellent. Joanna touched on before, part of scaling is support and maintenance. So we need to make sure we have all those parts ready to go to keep those trucks on the road. All right, so last one for each of you. What is one thing you want the audience to know about autonomous technology today? Started with you, Soroush.
I think there is kind of this conception that autonomous technology may be quite further out than people may actually realize. I think real work happens really in the times where maybe fewer people are paying attention. Obviously, we've gone through the hype and cycle and the trough, but we've been working heavily in the past number of years. We've been working together for quite some time already, and even since our last conversation at CES, we've made significant progress, and we are fully committed in bringing this technology to the market. We, as a supplier, are ready. We're working to bring Atlas, our product, to high mass volume production application. I think the timing for getting our SOP in 26 and for market entry by Daimler Truck in 27 is something that's actually kind of around the corner. So I think that misconception of highway autonomy being something that's much further out is going to be, I think, a bit of a surprise for folks.
Over to you, Joanna.
I think, yeah, well, no, actually I have 3 things, so sorry for that. But just real quick, I think there's 3 key ingredients for success for autonomy. On one hand side, you need the right platform that is scalable and that is modular. You have to have the best partners in this game, and that's why we have Torc Robotics, that's why we have Aeva. And at the end of the day, you have to take your customers with you throughout the entire journey, from the development phase to the deployment. And I think that's what we're doing really well. So,
Peter, last word.
I think now is really prime time, and it's with autonomous trucking, and why? There's a real need in the industry and the technology that can solve and fulfill this need. And I think that's all you need, and it's coming. As we said, we are now in a phase where we build a product and build a business. The prototype phase is over. Super exciting.
Excellent. Thank you, guys.